Hi future doctors, welcome to the next class. In this class we will discuss sharpness of resonance, LCR circuit and quality factor or Q factor. So for this you require some definitions, half power frequencies and resonance condition. What is the resonance condition? XL is going to be equal to XC. XL means omega naught L. XC means 1 by omega naught C. So from this you will get resonance frequency F is equal to 1 by 2 pi root LC. Already we discussed those. Next, what is the current passing through that? I naught is equal to V naught by Z. Z is going to be root R square plus XL minus XC whole square. Isn't it? Next, in place of XL we will write V naught by root R square plus omega L minus 1 by omega C whole square. So what is the graph drawn between, what is the nature of the graph drawn between current and frequency? Here square means whole power 1 by 2 will be coming. Therefore, it is curve. How that curve is going to be coming means, if it is current and the frequency or angular frequency omega or F we will take. So it will be coming like this. At one particular value, current is going to become maximum. So that particular value only we are calling it as omega naught. In terms of frequency, F naught. This is resonance frequency. This is resonant angular frequency. Both are going to be same. Next, so we have to define half power frequencies to get quality factor or sharpness of resonance. So what is this half power frequency? So this current is going to become, maximum current is going to become 1 by root 2 times. So that 1 by root 2, let us assume it is coming here, 1 by root 2 times of this maximum current. So here we are going to get one frequency omega 1. Here we are going to get another frequency, angular frequency omega 2 or F1, F2. So omega 1, omega 2 we will call angular frequencies. At two angular same frequency, means different frequencies, we are going to get current is going to be same, that is 1 by root 2 times of maximum current, isn't it? So in case of vertically projected body, a point B is crossing two times in time t1, another one in time t2. So but this hitch is going to be same like this. This maximum current 1 by root 2 is going to become at two angular frequencies omega 1 and omega 2. So why we have taken this one only? Why we have taken that one only means at this current power is going to become half. How it is going to become half means our power formula in AC. So VRMS, IRMS, cos phi. So VRMS is IRMS into Z into IRMS, cos phi is R by Z. So IRMS square R. So because V is equal to IR. So if V is equal to IR in LCR, VRMS is IRMS into resistance means impedance of the circuit. Correct? Now at this current I naught maximum by root 2, this is going to become I naught maximum by root 2 whole square R. So I naught maximum square R by 2. This is nothing but again power. Correct? P naught by 2. So therefore, P naught by 2. So this is P naught by 2. This is going to be coming at this current. Therefore, power is going to become half. At which angular frequency power is going to become half? That frequency we will call half power angular frequency or half power frequency, because omega and F both are related, because omega is equal to 2 pi F. Next, now what is the bandwidth? How we are going to define? The difference between two frequencies, half power frequencies, F2 minus F1 or angular frequencies, omega 2 minus omega 1 is called bandwidth. This is the definition for bandwidth. What is the sharpness of resonance? Sharpness of resonance or quality factor is going to be omega naught by bandwidth. Resonant angular frequency by bandwidth, or F naught by F2 minus F1 or omega 2 minus omega. Omega naught by omega 2 minus omega 1. So from the diagram, what is omega 2 minus omega 1 we will say. So from here to here that is omega 1. So from here to here this is omega naught. This difference we are taking delta omega. This difference I am taking delta omega. So from this diagram, omega naught is equal to omega 1 plus delta. Omega naught is equal to omega 1 plus delta double. Next, from this diagram, omega 2, isn't it? Omega 2 is equal to omega naught plus delta double. So from this omega 1 is omega naught minus delta double. So these two are very, very important. Omega naught minus delta double. So if you subtract omega 2 minus omega 1, what we are going to get? This minus this. What will be cancelled? So minus this 2 will be cancelled. Delta omega 2 delta. Next, another relation also will be there. If they multiply these two, omega 1 into omega 2. So what they will write means omega naught plus delta omega into omega naught minus delta omega. So at the time, omega naught into omega naught square, omega naught into delta omega minus delta omega plus omega naught into delta omega minus delta omega square. So whenever delta omega is small, this will be neglected, these two will be cancelled. Therefore, omega naught square equal to omega 1 omega 2. So omega naught is root omega 1 omega 2. I hope you people are understanding, because so this is going to be relation between resonant angular frequencies and two half power angular frequencies. In place of omega naught, 2 pi f naught, 2 pi f1, 2 pi f2. So 2 pi f naught, 2 pi into 2 pi whole square if it is coming outside, 2 pi root f1 f2. These two cancel. So f naught equal to root f naught means root f1 f2. So that is about relation between half power frequencies, half power angular frequencies and the resonant angular frequency. And omega 2 minus omega 1 we got 2 delta omega. This is only we are calling it as bandwidth. So in place of bandwidth or f2 minus f1, omega 2 minus omega 1, what we can write? 2 delta omega. So therefore quality factor. So Q factor is going to be omega naught by 2 delta omega. So now what is that omega naught by 2 delta omega value it is going to be, or equation it is going to be coming. So one thing you got already, omega naught by 2 delta omega. In terms of LCR or LC, how it will be coming, we will see. So for that, this equation we are going to use in place of omega 1 or omega 2 will take. We will see now how it is going to be coming. Now see, omega 1 is omega naught minus delta omega. Omega 2 is omega naught 2 plus delta omega. Anything you can substitute in this equation. At this frequency, what is the current we got? So current is going to become I naught this maximum by root 2. So at the time, V naught by root of R square. So whenever current is going to become this much, you can substitute either omega 1 or omega 2. Any one you can do. If we are taking omega 2, substitute here. So omega 2L minus 1 by omega 2C whole square. So in place of this omega, you can substitute either omega 1, omega 2. Any one we can do, just I am doing with omega 2. Now in place of this I naught maximum. So I naught maximum is equal to V naught by R. Did you remember? Whenever XL equal to XC, so I naught maximum from this equation, it is going to be V naught by root R square. So V naught by R, substitute here. So V naught by R into root 2. In place of this I naught maximum, we wrote V naught by R. So V naught by R root 2. So V naught by root of R square plus omega 2L minus 1 by omega 2C whole square. Correct? Next, if we cancel this V naught, numerator 1, denominator root 2R is equal to square root of R square plus omega 2L minus 1 by omega 2C whole square. Squaring on both sides, 2R square equal to R square plus omega 2L minus 1 by omega 2C whole square. So 2R square minus R square, omega 2L minus 1 by omega 2C is going to be equal to R square. Correct? Then omega 2L minus 1 by omega 2C equal to R we got. Now what is omega 2? Omega naught plus delta omega. Substitute here. Omega naught plus delta omega minus omega naught plus delta omega C. So we can take omega naught L common. Omega naught L common. So 1 plus what will be getting? Omega naught is common means delta omega by omega naught. So L is outside, omega naught we brought outside. So this one omega naught common, 1 by omega naught C, 1 plus delta omega by omega. Isn't it? Now omega naught L equal to 1 by omega naught C. So if you write in place of 1 by omega naught C as omega naught L, omega naught L, so 1 plus delta omega naught. In place of this what we can write? Omega naught L. If we are sending this one numerator, 1 plus delta omega by omega naught whole power minus 1. Correct? So again you can take omega naught L common. So 1 plus delta omega by omega naught minus, here what will be coming? 1 minus delta omega naught by omega naught is going to be equal to R. So 1 plus x whole power minus 1 is almost equal to 1 minus x whole power n, 1 minus nx. Like that whole power minus 1 here plus minus is going to become. So I am taking omega naught L common from both here and here. So omega naught L. So 1 plus delta omega by omega naught minus 1 minus into minus plus delta omega by omega naught equal to R. So these two will be cancelled. Then this is going to become omega naught L into 2 delta omega by omega naught is going to be equal to R. So what is omega naught by 2 delta omega we said? Omega naught by 2 delta omega. Omega naught by 2 delta omega. What we said means if you bring left side omega naught L by R. So if you compare this equation, this is very important equation. So how we are going to get? So how we are going to get means we will see here. So from this equation, omega naught by 2 delta omega is omega naught L by R. So this omega naught by 2 delta omega we said quality factor. Correct? So if you cancel omega naught and omega naught, so 2 delta omega is going to be equal to R by L. This is nothing but bandwidth. Okay. So here we have taken omega naught L common. We have replaced 1 by omega naught C as How we replaced? Omega naught n. So if you replace omega naught L as 1 by omega naught C, then you will get here in place of R by L 1 by CR you will get. Therefore, all the formulas are going to be same for us. How we will write very simply means already we discussed omega naught is 1 by root LC. So that one we can substitute here. Otherwise, omega naught by 2 delta omega naught L by R. So this one only they will write 1 by omega naught CR also. If you write omega naught as 1 by root LC into L by R, 1 by R root L by C, either from this or from this. So all these are the equations for quality factor. So quality factor and half power frequencies and bandwidth. So 2 delta omega 1 by CR you may get, you can cross check once. So this is about quality factor, sharpness of resonance, isn't it? I hope you people understood. This derivation is not required for you. So these final equations are going to be very, very important. So ratio between angular resonance frequency and bandwidth, we are calling it as quality factor, isn't it? So bandwidth means difference between two half power angular frequencies or two half power frequencies, isn't it? I hope you people understood. You can practice problems on this. We will see in our next class. Thank you.